Okay, so maybe we wait an extra 2 minutes for everybody to come in, and then we can start.
I just call it Juan.
Okay.
He's unresponsive. I hope he doesn't mix up the time zone. Yeah.
Okay. Okay. We will wait 2 minutes anyway. Yeah.
Yeah. Marilyn, can you hear me, Meryl?
Yes, I can hear you very well.
Okay, yeah, because I'm having some issue with my computer. I'm not able to, for some reason, it's not muting me. So
don't worry.
My cursor is working, but when I tap on mute, I'm so sorry. I don't know why.
It's okay. It's quiet where you are anyway.
Okay, thank you. I apologize if there is any noise. I'm not able to mute myself.
Okay, no problem. Okay, I think to avoid people's waiting, we can maybe start by the introduction. So I want to say good morning, good afternoon, and good evening from wherever you are joining us today. We are delighted to have you in this special webinar, and welcome to this panel discussion, which addresses the role of Earth observation in crisis and disaster management in emerging markets. I am Dr. Miray Al-Haj, the founder and CEO of Astra-Terra, the organizing company. I'm also an honorary senior lecturer at Imperial College London and a researcher in positioning, navigation and timing, system engineering and interference in the Civil and Environmental Engineering Department. I will be today's moderator for the panel discussion. So I will start by introducing the organizers and then ask each of our distinguished panelists to introduce themselves. So starting with Imperial College London's new Centre of Excellence for Active Resilience and Security, the name is CARS. The Centre is committed to understanding and addressing the challenges that act across multiple levels of societies and developing solutions for reactive, proactive, and predictive threat detection and recovery, ensuring the highest level of societal resilience. Astra-Terra is a boutique consultancy based in London that specializes in intelligent transport systems, smart cities, and space technologies and applications with emphasis on PNT, that's positioning, navigation, and timing, Earth observation, and space sciences. Our expertise lies in providing strategic thought leadership and driving innovative solutions in partnership with governments, universities, businesses, and societies. So now we do a brief introduction of our panelists in alphabetical order. If I may ask Mr. Alejandro Roman to introduce himself, please.
Yes, good morning, good evening, good afternoon, everyone. First of all, thank you very much, Mariel, for the kind invitation. Thank you also for to the Imperial College and Astra-Terra. My name is Alejandro Romans. I'm chairing the Developing and Emerging Countries Committee, which has 5 regional subcommittees at the International Astronautical Federation, IAF. My current role is the General Director of Execution and Aerospace Development at the Paraguayan Space Agency, and I am also an undergraduate and graduate professor at the UNIDA University in Paraguay. And I'm also a member of the Executive Committee of the Group of Earth Observation GEO. It is a great pleasure and honor to be here. Thank you very much.
Thank you so much. Mr. Andrew Eddy.
Hello, everybody. It's a pleasure to be here as well. My name is Andrew Eddy. I am president and CEO of Athena Global, which is a management consultancy specialized in the application of satellite data to environmental issues and disaster risk management. I am the founder of Athena Global and have been working in public and private space sectors for about 30 years. And I am also closely involved with the Committee on Earth Observation Satellites, where for the past 10 years, I have served as secretary to their working group on disasters. And it's a pleasure to be here.
Thank you so much. Mr. Gijs Wendendoel, please.
Yeah, thank you so much, Maria, for the invitation. I'm Gijs Wendel. I'm an independent researcher, currently working on Earth observation, remote sensing, and moving the Internet of Things to the more remote places like the forest in the Amazon. I'm working with Astra-Terra on several innovative projects and have an extended experience in natural catastrophe modeling for the reinsurance industry, where we blended the traditional probabilistic models with forward-looking parametric models for both the residential markets and agricultural markets. Thank you so much for.
Thank you. And we will discuss some of this in the webinar. Now, Dr. Juan Carlos Villagrán de Leon, which I believe could not join us, maybe it's a confusion with the British summertime. He is the head of the UN Spider Program for Outer Space Affairs in Bonn, Germany, where he oversees knowledge management, disaster risk management, and early warning efforts. He's the desk officer for Latin America, the Caribbean, and Africa, and represents the office in the International Network on Multi-Hazard Early Warning Systems. We hope he can join us eventually, but then I'll move to Dr. Namrata Goswami, please.
Yeah, good morning, good afternoon, good evening, and Meryl, thank you for having me. It's a great pleasure and honor. So my name is Namrata Goswami, and I am also an independent researcher. In my capacity studying space policy and international relations, I teach at the Thunderbird School of Global Management, Arizona State University. I also teach with the Joint Special Forces University. And in the last decade or so, my focus has been on looking at the space policies, institutions, funding, as well as societal support for different space missions, policies, international partnerships. And I'm delighted to be here and contribute a little bit of the developing world's perspective on Earth observation. So thank you for having me.
Thank you. Dr. Philippa Mason.
Hi. Hi, everybody, and thank you very much for the invitation to such an exciting panel session. I'm a senior lecturer in Imperial College in the Earth Science and Engineering department, a little way from Mirel, and I wear many hats, but I guess I would describe myself as a remote sensing geologist, working on Earth primarily, but I also have a planetary hat, which relates to a question which will pop up later. And I'm involved in applying and developing techniques using satellite data and other data from other platforms at the interface between the natural world, the geological, geoscientific world, and the urban world, the infrastructure, and also in the environment. So I sit at that interface, and where the natural hazards are very much at the core of one of our focus points anyway in this department. I also am the co-leader of our college-wide Earth Observation Network, which is a relatively new initiative to foster collaborative links between different disciplines, physics and aerospace and geoscience and life sciences, all of which are very much interested in the exploitation of this wonderful technology that we have, which we call Earth observation. Thank you.
Thank you so much. Okay, thank you. So before we start with the questions to our panelists, I will briefly outline the discussion's format and rules. We will have this webinar in a mute format for our audience and participants. The panel discussion will last for an estimated 70 minutes with 20 minutes for Q&A from the audience. Please put your questions in the chat box and we will try to address them after the panel discussion. So we will tackle the subject of our webinar from various angles, the first being development and impact. Then we will talk about the disruptive technologies, the related business models and capacity building. Finally, we will discuss governance and international collaboration. So finally, I wish you an enjoyable webinar, and I will start with the questions. So my first question is actually for you, Philippa. Philippa, Earth observation is a comprehensive mechanism that can be accomplished through various means and tools, ranging from space-based platforms to terrestrial technologies such as computer vision, for example. Could you provide us with a precise definition of Earth observation and elucidate its relationship with remote sensing, please?
Possibly. That's quite tricky. So I've been asked this question many times, and I've witnessed many arguments about what's the difference between Earth observation and remote sensing. So without wishing to cause any kind of ructions amongst the panel, I think that remote sensing and Earth observation are essentially the same thing. So remote sensing was the first term originally coined, I think, in the 1960s. And it is generally, it is made, I think, mainly adopted as the more general term. And so if you look at the definition, it's something like remote sensing is a mechanism for collecting data about an object without actually being in contact with it. So it is a term that we can use in general to all kinds of sensors on Earth, whether they are on a moving platform or a static platform, a tripod or a robot or something, but also an aircraft or a drone, or also on a satellite. So for planetary observations for other planets, we have to use remote sensing because we can never get there. So that's a good term for the more general case. Earth observation is generally accepted as a term that involves observations of our planet, but specifically, I think people tend to refer to Earth observation when they're talking about satellites, about spaceborne platforms. And that includes a huge variety of different types of sensors on board multiple satellites that are routinely orbiting the Earth at a variety of different orbital heights and distances to achieve very different things, exploiting all wavelengths, from extremely short to extremely long, and all the technologies that are involved in those the sensors, the data that comes from them. And then I think you also mentioned computer vision and those other kind of methods that we employ to process and handle the data and to extract information from them. And therein is the kind of the where everything balloons off into a whole range of other exciting and novel applications of machine learning, deep learning, artificial intelligence, and the tools that we are now beginning to use and develop, and that are essential, really, if we're going to handle the incredibly large and expanding volume of data that is now coming. We're sort of sitting on the pregnant edge of a revolution, really, I think, in terms of data volume from Earth observation that's going to help us manage the planet. So that's how I see it. Others may disagree.
Okay, so anybody from the panel would like to add to Philippa's answer? Are we happy to move on? Yeah, and
I'd just like to make one point about the pregnant edge. I strongly agree. I think we're on the cusp of something really important. We have collected data for a long time, but the volume of data we've collected up until now has kept us actually from being able to properly exploit the data. And when people think of satellites, they tend to think of imagery, they think of a photo from space, but there's a lot more than that. When we're looking at active sensing, for example, with radar, it's one thing to see through clouds, but it's quite another to make these radar stacks and with SAR interferometry start to look at, sub-centimeter level changes. Really we're able to calculate when the ground is going down millimeters in places, and be able to predict the failure of critical infrastructure. So what do we do with all this data? And now we've come to the point where computing has caught up. And we're starting to look at things like machine learning and artificial intelligence that are allowing us to do a lot more with data than we were even a very short time ago. Even in the last 18 months, we're seeing new things coming about. So I think I like the word pregnant edge. I would have said cusp, but yes, something is about to change big time.
Yes,
and I think it's really exciting for the field that we're working in.
Well, thank you so much for this. Actually, the second question is for you, Andrew. The United Nations Office for Disaster Risk Reduction has issued a sobering warning, and I'm quoting here: "The world is to experience more than one disaster a day by 2030. Now, this grim projection underscores the gravity of the situation. Could you shed some light on the current status and the significant challenges that lie ahead for the Global South and North in confronting this daunting reality?"
Well, I think that it's no secret to anyone that the world is changing very quickly. We are grappling with climate change already. And what we're calling disasters is really just it's the impact of natural hazards that's changing, because there are many more of us, and we live in very vulnerable areas. We live in coastal areas. We live close to places that are dangerous. So yes, there are going to be more and more disasters as the climate changes, as we experience more and more severe weather events, as we come into an era of sea level rise. Things are going to change pretty quickly. I think what we need to be doing is not just monitoring how things are changing, but starting to use this data to increase resilience. Because really, if we want to reduce disasters, what we have to do is become more resilient. We can't change the fact that an area is going to flood, and it's going to flood more often. It might flood more violently. I'm traveling right now, but I've just learned that my home is flooding, not the house itself, but the area I live in is experiencing record floods. And this is nothing new. We are going to see more and more events like this, but we can become more resilient by better understanding where this is going to happen, how it's going to happen. I've worked on projects with colleagues where we have been able to simulate future disasters, future events, and better understand what the risk of these things are, to be able to reduce that risk by building differently, by rethinking, how we go about this. I give one very concrete example of a gentleman I met from the Philippines who owns shopping centers, who bought cheap land in a floodplain, and everyone laughed at him, and he built his shopping center on stilts. And when the floodplain eventually flooded, his shopping center was actually a place where people came and took refuge and were able to be sheltered from the flood. And I think we have to start thinking more in terms of living with risk and becoming more resilient.
Interesting story. Thank you. Okay, now that we understand the problem a bit better, let's delve into solutions. So Philippa, again, as a geological remote sensing expert, the world is currently grappling with environmental security and hazards. So like Andrew was saying, rising sea levels, earthquakes, volcanoes, and hurricanes in the face of a changing climate. Could you elucidate how Earth observation and remote sensing can provide solutions and strategies to address these threats? And how does that differ when it comes to emerging countries, if there are any difference, of course?
Sure, I think there's lots of levels to that question, and the first is in the terms natural disaster. Well, I think that needs to be separated out. We have natural hazards and the events all those events that are encompassed by that term, and then we have disasters. I don't think there are any, natural disasters. There are natural hazards, and what we want to do with all of the data and the tools at our disposal is to tackle this problem of natural hazards, to understand them, and to prevent disasters, because a disaster is a kind of a thing which involves people, and if you look around the world, and we have our vulnerability is associated with where we live, and our incomes, the economy, but we are vulnerable. And Andrew talked about resilience a little while ago, and I think that's the thing that we have to do. We can't stop these things happening. They are a factor of the natural environment, but we can improve our resilience. And if you look at charts available on the web about the number of reported natural hazard, or actually it says natural disaster, but it means natural hazard events, earthquakes, volcanoes, landslides, etc. The number of recorded has gone up a lot, and that's partly to do with recording, but the number of deaths has gone down because we are getting better at managing the problem. Forecasting is a controversial thing to talk about. We can understand volcanoes better, much better, and there is now a kind of traffic light warning system in place from organisations like Comet, which you may or may not be aware of, who monitor 180 or 200 of the world's most active volcanoes using satellites, using INSAR, using interferometry radar. They are now able to sort of monitor the behavior of the volcano to say, is this a worry or not a worry, and should we do something about it? So we can do things with volcanoes. We can understand landslides better. There are all sorts of models, global models now, to kind of predict where landslides might be about to occur on the basis of rainfall and slopes, etc. Earthquakes are challenging. We understand a lot about them. We can map the deformation after the event, but predicting them, forecasting them, this is challenging and in science fiction still, but we're getting closer. But what Earth observation is brilliant at, as well as mapping out these things, is helping to manage the mediation efforts where aid is focused. If you can recall back to 2004, the Banda Aceh earthquake and tsunami in Indonesia, it was the first sort of time when the news was everywhere. There was a problem, was enormous. There must be satellite data which can help us to distribute aid. And after that date, satellite data was given away free for natural disaster mitigation and mediation and aid efforts. Before that, no. So there was a sea change in our attitudes and our public realization that we needed data, we needed maps, we needed spatial information. Where is the problem? Where is the flood? Where are the damaged houses? Where are there people stranded? How do we send our ambulances and our aid workers to the sites? And so there are so many elements to this problem, and Earth observation and remote sensing can help with all of them. Preparedness, resilience, mediation, aid, etc. But also, as a natural scientist, a geoscientist, I'm also interested in understanding where they happen and why they happen. So I'm interested in both of these things. But Earth observation certainly offers us a lot of opportunities to tackle both of those elements, both the natural part and the preventing the disaster. And I see that we don't have answers to all these things, and we don't have tools to deal with them all. But these are the spaces that we're all operating in. I think that's what I would say. And then the last part you said is, does it matter? Is it different from emerging countries? And the answer is, in practical terms, yes, of course, because they don't have the infrastructure, the economy, the strength of the economy, the resilience. Take Japan, for example, which is an incredibly earthquake-prone region. It's sitting on the ring of fire. It's densely populated. It's in a terrible place, really. I wouldn't design cities to sit in those locations, and yet they are the most earthquake-prepared country, and they know exactly what to do when there's an earthquake coming. And so their death toll and their engineering regulations are the best in the world. So they are resilient, much more resilient than, say, Haiti, where we had an earthquake disaster not that long ago, and there was effectively no government, no services, no power. They were reduced to rubble. So yeah, there's a difference, and we have a responsibility as a mature nation, a mature economy, all of us, to assist. And organizations like the UN have a unique kind of role in coordinating all that, and so do the aid agencies. So I think this is a really complex question you've asked, and I can't give you a single simple answer, but I think that sets the scene for a whole lot of other conversations.
Absolutely. Well, thank you for highlighting this to us. My understanding is that such solutions require tools and methods. So Hayes, we hear a lot about modeling and data processing. As a renowned modeling expert, what is the role of data modeling in Earth observation and crisis management?
Yeah, so that's a good question. I think it comes on. It touches on what Philippa was saying, that how prepared are you? So how accessible is that information that you have, and how well can you model and start building your digital twin to say, what will my city, what will my infrastructure do under certain stresses? And that's where that modeling comes in, and putting in the vulnerabilities and the resilience of that infrastructure, and so getting to know what it means under certain stresses, what happens. So if you have a flooding happening, till where does that flood extent happen? Are critical infrastructures affected by it? Should I improve my defenses, or even remove my critical infrastructure away from those flood plains? So it is about preparedness, and that's where I think data modeling comes definitely in as a first tool to the crisis preparedness. And after that, in the event itself, you can also think about what is your model going to do, and start playing with routings and making sure that the aid workers are getting the supplies where they need to be, because you will have business interruption happening if there is a heavy earthquake. Then you can't forecast where the roads are that are being affected. But if you have the Earth observations and within a certain amount of time, especially when the information is made available for free at a timely manner, then you can get that planning up and running.
Thank you.
And then,
can you, sorry, like, could you briefly maybe discuss the innovative business models, including reinsurance, because we know you work in that domain as well. How can that aid emerging countries in particular?
Yeah, so that kind of comes back to the introduction that I gave, that when you are going into those emerging countries, you won't have the direct experience of having the probabilistic models readily available, like many insurances have invested in a very good and decent model for the US and very decent model for Western Europe. If you go to Kenya and to Malawi, for example, those models are not existing, but the economies are growing. So that's where, for example, parametric solutions can play a role. And one of the direct inputs for a parametric solution is an Earth observation, where you can look at the trends. For example, the Landsat data will give you a long time series analysis that you can say within certain uncertainty bands, we can see that there is a yield deficiency when rainfall is not at the certain levels. And then you can say, okay, when we see an extended drought period, we can see that the yield will be less. We can insure you for that. That's one of those examples where parametric solutions can play a role.
Yeah, thank you so much. I mean, good news that Kenya has launched its first Earth observation satellite. So let's see how would this help. I think now that we have heard from some of the tools and business models, Alejandro, the question is for you. Consider the case of Paraguay, an emerging nation, and its cooperation with neighboring countries, possessing more advanced facilities. Could you shed some light on the models of international collaboration, including data sharing, given that you often collaborate with NASA, UN SPIDER, JAXA in Japan, and other neighboring countries like Brazil? And the second part of the question is, are the existing models fit for purpose? And if not, how can they be enhanced? Or do we need to explore new paradigms?
Thank you very much. Well, let me bounce back a bit with the point that Andrew has mentioned about the Global South. I think the Global South may face greater immediate challenges due to vulnerabilities and capacity constraints. But the increasing frequency of disaster poses a significant risk and challenges for both the Global South and the Global North. We are living in the same rock, and we are facing the same challenges. Inevitably, we need to think about us as a whole. Addressing those challenges will require comprehensive and collaborative approach. Going to your question, the international collaboration, for example, including data sharing and other models and tools, is essential for countries, emerging countries like Paraguay, for example, to leverage and to advance in facilities and expertise, especially for neighboring nations and international organizations. For example, in disaster risk reduction, we have collaboration with NASA, as you mentioned, and also with UN SPIDER, space agencies like ESA, JAXA, and also neighboring countries like Argentina and Brazil. They help us a lot when we have these events. In 2019, for example, we have a big flooding that affected more than 100,000 families. We received the help of these space agencies, providing, for example, we activate the International Charter for Space and Major Disasters, and we received a huge amount of data, but raw data, and the national capacity in the Paraguayan Space Agency wasn't yet there. And we asked our colleagues on NASA, USGS, CONAE in Argentina, and Imperial in Brazil to process those data for us. And we managed to deliver more than 200 value-added products to the National Emergency Secretariat to improve the decision-making process. Just to give you an example of how we can work. And also, I see my good friend Juan Villagrán, he's joining. Also, UN SPIDER was instrumental in these capacity building activities with experts. They sent a technical advisory mission with 6 experts from the region that helped us, Paraguay, to build our own capacity. And for example, while the existing collaboration models has been beneficial, there is still room for enhancement, of course, to ensure they are fit for purpose, as you mentioned, and effectively address the evolving challenges in DRR, in disaster risk reduction. For example, I can mention we can strengthen data sharing mechanism. We can promote capacity building and technology transfer more strongly. We can facilitate cross-border collaboration. We can encourage open data policies even more. And regarding the risks that you mentioned, this is the last part of the question, that is associated with collaboration. One possible solution can be the diversify the partnership, not rely in just one single source. That can be one key point. Build our I say from Paraguay perspective, but all emerging countries perspective, a local capacity. Invest in education. This is key. Training. We cannot develop solutions or use the infrastructure if we don't have the knowledge. First, we need the knowledge. Absolutely. This is the foundation. And also promoting sustainability. Every dollar, every pound, every guarani, this is Paraguay currency, we invest in the needs to return applied science. It needs to return in a benefit in a certain way. This is, for example, some points that I can mention, like how emerging countries can enhance our collaboration, mitigate risks. We cannot avoid them, and effectively leverage international expertise. This is one of the key roles that we are pushing on the IIF Access Committee. Thank you very much.
Thank you for the answer. And before we move on, I just want to welcome Dr. Juan Villagrán Leon. You were late, most probably it's a time difference, I believe. I've introduced you at the beginning of the webinar, so I don't know if you would like to say a few words or we shall carry on. Would you like to say something before I continue?
Let's carry on. Apologies, I got sidetracked with the GMT.
Sorry, because we just changed the time recently in England, so it must be confusing. Okay, well, thank you so much, Alejandro. The next question is actually for Andrew again. So we heard from the case of Paraguay, the lack of in-country facilities and how they deal with it. Now, as a global expert who has worked across various continents with diverse capabilities, when discussing disparities, what approaches could be employed to address these disparities? And should each country or region consider acquiring or developing its own national or regional capabilities? Given the capital-intensive nature of the space industry, are there any viable solutions you could guide us through?
I think that's a great question, and I think Alejandro has already started to address it. The capacity, education, these are absolutely critical things. I think we have to get a little bit away from the idea that every country needs to have their own satellite. We now have a lot of capacity out there. I'm not saying that we don't need more satellites, but I think we are all part of the same rock, as somebody just said. We're sitting in the same place. We have a lot of shared resources. Some of them are open, and I strongly encourage more resources to make their data freely available. Some of them are commercial, and I think we need to find better ways to marry publicly, openly available data sets with commercial data sets. These commercial satellites offer very valuable information, but we don't want to just use that data in isolation. What we really need to do is combine the commercial data with the open data in applications that are driven by themes that we're interested in. You know, if you're working on a flood theme, then you need different types of satellites that do different things. And if you're working in an urban environment, then you need a different type of data than if you're working in a rural environment. So we need to use all these tools at our disposal. And when we talk about increasing the capacity especially in the developing world, I think what we need to be looking at is increasing the capacity to use what's there, not to build new satellites, but to better exploit the things we have, to have funding for value adding, because we can have all the data we want. If we don't have resources to actually add value and extract information from the data, we might as well not have the data. So this is really critical. And that doesn't mean that there aren't new things happening all the time. I was talking earlier about machine learning and data sets. Just in the last 18 months, we've started to reprocess satellite data from radar satellites. Sorry, I'm getting a bit of an echo, I think, from Namrata. We're starting to reprocess data from radar satellites, and it allows us to see things in urban environments that we didn't see before, because we're able to reduce the noise, and get a much better idea of where the water is in urban environments. So that's a great application, but we don't need a country to launch a new satellite for that. What we need is to share these tools, to share these methodologies, to increase the amount of cloud processing we do so that people anywhere in the world can access the cloud, process there, and download an information product. So I want to echo Alexandro's call for more open data sets, but I also want to add a layer on resources for people that don't have access to the commercial data sets. The commercial world is not going away. In fact, it's growing exponentially. There are all sorts of exciting new radar, in particular, applications coming out of the commercial world. And so we need to make those tools also available to people that don't necessarily have the resources now to access them. And that's really a critical piece of capacity building. It's enabling people that don't have the capacity now to exploit what's already there.
Thank you, Andrew. We're actually staying with you for this next question. So considering the various constellations that already exist, we know that GEO is typically for communications, surveillance, and navigation. MEO is for positioning, navigation, and timing, so that's PNT. And LEO is where Earth observation and other satellites reside. Then we descend to the Earth airspace with sensor-mounted balloons, drones, and aircraft. And closer to home, we have technologies such as close-range photogrammetry and computer vision. Now, combining all these data from multiple platforms, what do you see as the challenge and the potential added value to crisis and disaster management? And should the world be working on establishing a worldwide or at least continental holistic platform for crisis management, something similar to, I don't know, digital twin continental? And what are the challenges there?
Well, there are huge challenges, not the least of which are organizational, but even from a technology point of view, it's not a simple thing to take imagery from a drone and then superpose that on satellite imagery and extract information as if those were two interchangeable data sets. But there are very interesting ideas about having platforms that hover over disaster areas. People think of disasters in terms of disaster prevention. There's a huge early warning effort going on within the UN family right now. But also, I personally work a lot on the recovery phase of disasters. CEOS has kicked off something called the Recovery Observatory in partnership with the World Bank, with UNDP and the European Union. And that project on a demonstration level makes satellite data and information products available for a 6 to 9 month period following major disasters to have one integrated situational awareness picture, if you like, from before the event, what the baseline was, through the event, all the way into post-disaster needs assessments and the development of national disaster recovery framework. So to have access to all different types of data, to combine that with in-situ data and be able to look at the whole picture using the right data for the right purposes, that's really important. Do we need a global digital twin to do that? I don't think so. We absolutely should try to work beyond just the regional levels. Regional cooperation works very well. I'm working on a project right now sponsored by the European Commission in Latin America. It's taking the benefits from the European Copernicus program and trying to work on technology transfer, training, and capacity building throughout Latin America and the Caribbean. We're building a hub in Panama that will be an actual technical hub with cloud servers and other things and a mirror of all the Copernicus data sets. But that's also a huge amount of capacity building and training so that we stop seeing when there's a disaster, a consortium of European or American companies producing a product that's given to people in another part of the world. We need to have the capacity in each region to develop information products because the people in the region have a better understanding of what the needs are, and they're going to develop a better, more applied product than what someone halfway around the world is going to do. So I think that's really where we need to put the emphasis, is on this integration. And you went through this whole range of GEO through LEO, right down to Earth. We need all of those things. When we're looking at hurricane warning, we need to look at weather satellites that are very, very coarse in terms of resolution. But then when we get into the impact, we need, sub-meter resolution optical satellites to be able to see exactly what has happened. We need, in the cases of wildfires, to look at thermal information. All these different satellites doing different things, and there are a few that have really, we haven't thought of some of these applications before. I worked a few years back in Canada on a study for a Molniya orbit satellite. So this flying in a high elliptical orbit. So it comes very, very close to the Earth and then goes very, very far away, but it is able to stay over the same part of the Earth for a long time in polar regions, which is something that geostationary satellites can't do because they don't really see beyond 72 degrees. So all of these different ideas bring us new forms of data and information, but where we're really missing the resources now, in my opinion, is in the integration and the exploitation. We're missing that. We always talk about the last mile in disasters, get the information right down to the last mile. Well, we're not getting to the people that need it most because we're not able to synthesize and integrate and fully exploit all these tools. And I'm hoping that with these new computer technologies becoming available with machine learning and the ability to integrate at relatively low cost, very, very large data sets, we're going to start to see some changes in this area.
Thank you so much for this elaborate answer. That takes us to actually the next question with Alejandro. It's actually on capabilities. So when we speak of lack of capabilities, we spoke about lack of resources that include, like Andrew just said, knowledge, expertise, and training. On top of this is lack of awareness about space and how important space applications are, such as Earth observation, for sustainability and security. So what are your recommendations for emerging countries on these challenges? And how do we start addressing them? Are there any mechanisms you want to talk about?
Oh, thank you very much. Well, this requires a multi-phased approach because it has many layers. First of all, again, the foundation is capacity building, as I mentioned in my previous response. We need to implement a strong capacity building program in order to have the knowledge and to know where to find the data, how to process the data, and how to extract valuable information from there. These programs can be as training workshops or seminars, online courses. It doesn't need to be a master's degree or PhD degree, a large extended time necessary for building this capacity building, initial capacity building. Also, again, foster the international cooperation is a enabler that enhance the collaboration with international organizations. There are many international organizations that is making efforts in that direction, like UNSPIRE and others, that can help the developing countries or the emerging countries in developing these capacities. And also there are a lot of resources that is already there. As Andrew mentioned, there is a lot of data that is already in the portals, like a Copernicus program and the NASA data sets. There is already there that people doesn't know where to find the data and also doesn't know how to process that and how to extract, what kind of information I can extract. And also it's very important that the countries establish a national space agency or a commission, some organization that address this subject and develop initiatives in order to extract value from the satellite data. We need to increase the public awareness. We need to strengthen our education outreach campaigns. The general public needs to understand why and how the space can improve the life on Earth. We need to integrate space education in the curricula, for example. And also, again, access to open data platform is key for leveraging this. There is a lot of platforms already there, but we need to improve even more. With this, emerging countries and every country can independently use the resources available. And with that, we can begin address the challenges and also the lack of capabilities, resources, and awareness about the space applications. I think this can be a point of start. I think here is Hans Reis Mirev. Thank you very much.
Thank you so much for this. I will stay with this subject a little bit longer, and I want to ask Filippa. Filippa, as a senior educator at a world-leading university, and Gijs, also your experience as a mentor in various startup incubators, what criterion are necessary to assure ourselves that we have a resilient, holistic system in place for emerging countries? And what are the roles of educational institutions, centers of excellence, and startups in cultivating resilience? I know that Alejandro's touched on this, but I'd like to hear your view from a university and incubators point of view, please. So we start with Filippa.
Yes, this is a tough one, and there's lots of layers to it. I think it's been mentioned several times already about the importance of education, and the UK government as alone has identified a whole lot of skills gaps in industry that relate to the kinds of technical skills that are needed to really get to grips with the next generation of Earth observation processing companies, organizations. They need people. They need people with the right skill sets, and we have an important place in doing that. We've got to deliver the next generation of scientists who have the right skill set and the right mindset to tackle these problems and to bring all these things together. Like Andrew said, we need to be able to bring data together. We need to remove the barriers, basically, and put in place the right skill sets to exploit all this information. So I see that we have a huge responsibility to do that, and we in this organization, as you know, are working towards that. And I see every year, I see more students are interested. They're excited. They realize it's a problem, and the power of the technology is almost not quite unlimited, but it's expanding. So I think that's very important. In terms of criteria, what criteria are necessary to that's a really difficult one to ask, but this is an important part of it.
If you can think of any, not necessarily.
Yeah, I think equipping ourselves and removing barriers to the data, access to the data. Like tools like Google Earth Engine, which sits on the entire archive of Landsat and the Sentinel missions, and the fact that we can now develop these tools, these open source tools to exploit those data, they are free to everybody. Software, the price of software, proprietary software licenses, there's always been a barrier in the past, and we're moving towards, not away from them, they're still important, but towards being able to develop our own applications and tools. Those things, anybody who can access Python and use it, or whatever tool, and has access to the data, has the ability to provide something that is useful for their community. I think we would probably all agree that there's a danger in taking something on a local scale and expanding that solution to global. That's dangerous. So I think we need to be aware of the global, but also maybe to be working at the local and the regional, and to know which technology and which data is applicable, as Andrew said earlier, to those. So I think education is massive. Open source tools are vitally important. Data integration, data free availability, and removing barriers. I think those are my criteria.
Yeah. Thank you. I totally agree with you. Actually, I have a point here to make, and I think sometimes we need to educate universities themselves, because I've been in a certain part of the world, and they don't even understand the importance of education when it comes to Earth observation and space-based sciences. And it's about time.
A while.
Yeah, exactly. So we have a mission on educating those universities also on how important these sciences are, and they're not science fiction anymore, because they're very close to home and to our everyday life and disasters. Exactly. Okay, thank you. So Gijs, do you want to maybe touch a little bit on the startup, the role of startups and incubators?
Yeah, no, I can tell a little bit about that and where I see a problem. I have been mentoring, like you said, several, and one thing that is coming back, and that's coming also back in this discussion here, is the educational part, that people are seeing that the data is getting available. I was just going to touch on what Alejandro was saying, that there is not that, or what is happening at the moment is that different data centers are emerging. For example, there is the Digital Earth Africa, there's Digital Earth South America, the Amazon system is building its own system. The Congo Basin is building its own system. The Mediterranean system is also pulling the data sets together. So that's what you can see, that people are starting to integrate. We're there again at the forefront of the movement. Also that artificial intelligence, machine learning, deep learning technologies are getting more advanced. And that's then going back to what Felipe was saying, okay, we have Google Earth Engine. And that's where I see the problem, is that the data sets in the geospatial domain are quite different to what a normal machine learning engineer would do or would start to analyze, or how he would or she would look at the problem and fix the problem or develop tools. So that's what I'm seeing when I'm mentoring new startups that are trying to unlock that data, that there is a steep learning curve on what is this actually that we are looking at. What is geospatial data and how does it affect us? Even that it is known, or people are thinking that it is easily accessible, but then how to interpret it and how to make the right conclusions. And I think that's another thing that we are still in a domain that where we have to educate. What is it that what does that index mean if you are doing it? Because it is so easy to do the clicks to run the scripts and get a data layer, but what does it then actually mean? And how reliable is that data layer, and where is your uncertainty? So there's a lot of education and awareness in the data. So the data becomes available, but then with that knowledge comes also a price.
Thank you so much. Yeah. So now I would like to move to Namrata. Namrata, actually, this question that we've just discussed, the capacity or capability building, maybe it will be the second part of my question, but I'd like first to start with this one. So obviously we require policies, agreements, and treaties. If you could tell us about the current state of play and what are the challenges in the space domain and what future directions should be pursued.
Yeah, sure. And first of all, thank you for having me. And I really enjoyed listening to everyone's perspective here. So I think I'll break my answer into three parts. One is the policies. Second is the actual implementation of the policies, which includes institution, funding, education. And finally, the power dynamics that plays into this entire data that we are talking about, right? So in terms of policy, if you look across the world, I was looking at the US space policies, right from the Trump administration to Obama to Biden, there is a focus on Earth observation. And in fact, Kamala Harris in the latest National Space Council meetings, as well as others, have actually pointed out that it's very vital for the United States to be able to offer, for example, Landsat capability to the world, as well as build, for example, climate predictions, weather forecasting. And then if you look at the policies of, say, countries like India, China, who are contributing to this particular effort through their own capabilities, and then on to other emerging nations. For example, in Africa, Latin America, there is a lot of focus in terms of observation from the policy perspective. There are also the insistence on building United Nations supported Earth observation capability so that data is accessible and free and usable, right? So at the policy level, we seem to be doing okay, is my analysis. We seem to be having an awareness. We seem to be pushing for more and more data. We're also able to explain to each other at the level of peer review, academic conversations, that Earth observation capability is vital. Now let's break it down to institutions, and then let's break it down to actual funding and where it's used. So when it comes to institutional capacity, there are challenges, especially from the global south. And when I talk about the global south, I'm also going to break that down. I don't include India. I would include West Africa, for example. I would include certain countries in Latin America, some countries in South Asia. And I'll say that because when you break it down, what matters in terms of accessing the data is not just expertise, but power, access to electricity. And when you look at the International Energy Agency estimates, countries in sub-Saharan Africa, there are about 745 million people without power. Secondly, when you talk about artificial intelligence and cloud computing, that requires enormous amount of energy, good internet capability, broadband, to download that statistics. That's not available to a major part of the world. So when we talk about the large access of data, which is offered for free, first is, can you actually access the data? Forget about analyzing the data, right? So that's
Absolutely.
a very big challenge in disaster management. And then coming to actual implementation, now there again, when we talk about access to commercial satellite imagery, it is expensive. So while we say that we can integrate it, we can build that particular map for predictions, several nations do not have that capability to access that because you need money, funding. So funding is vital. Philippa was mentioning this as well, that how do we actually help through regional and international institutions to build that capability? And then finally, in terms of implementing the data itself, right? So first of all, you need very, very specific resolution capability. You need, for example, a 1 meter range to actually help in terms of prediction. That is not available in free data sets at times, right? And for example, you do have that kind of resolution capability, but that sometimes is classified. For example, in the US, what they're talking about as a challenge for Earth observation is access to that kind of specific data mapping and building from Earth observation and integration of that to say Earth-based or observation, for example, using drones, right? So we would say that, okay, let's use cloud computing, let's use artificial intelligence, but that kind of capability requires that first thing, which is power, the ability to download, right? When we're talking about developing nations. And so I'll end by saying that what is the solution? The solution is one, funding. Funding is vital. Funding capability, funding communication to policymakers. So one of the challenges that I heard when I talked to people who actually implement policy in Africa, Latin America, Asia, is that while the Earth observation scientific community knows about the data, knows about the technologies, there is an absolute lack of an ability to translate it to policymakers. What exactly does it mean to have this data set? What does it mean for specific country policies? What kind of institutions do we require, right, to actually implement that policy? So this is the challenge, to translate our knowledge, our technical expertise to actual policy making and specifying how much money is required. That is a big challenge. And I'll finally end by saying that you'll be surprised to know that societies do not trust sometimes the Earth observation data given to them because of the element of power and decision making. So several communities in West Africa, for example, and some remote areas in Northeast India and Burma, they are very uncomfortable with the Earth observation data predictions and analysis given by their governments because they do not trust them. And so that's a major challenge as well. So I'm going to end there. So trust building, transparency,
Absolutely.
mediation. Yeah.
Yeah, thank you so much. Now, this question is about, I know, you're a teacher, first of all. So what role does, let's say, your education play in building that trust, if it does? And where do you see the value in educating people on policy and the importance of agreements and treaties?
I think in my own experience, what has really worked is educating, not just, so education has to happen at different levels, right? One way that I have been able to use my educational capability is to not just offer the scientific or the policy analysis from a theoretical perspective, but also build in simulation. So actually give policymakers an actual crisis and make them go through it, right? So that's how they actually integrate the knowledge. And when I talk about workshops as well, what is one of the best ways of building trust is to build different stakeholders into the process. So for example, when you talk about, say, Earth observation, let's build a workshop around that. You would need the policymaker at the highest level in a particular country. You'll need the funding entity, you'll need commercial, you will need educators, you will need academia. So when you bring all that together, in some sense, trust can be built. I'll finally end by saying that in terms of my education, what I do even more is that I actually also kind of bring space policy analysis at the local level. So engaging local stakeholders, we talked about this, but that does not mean only the government entities. It also means people who are actually, for example, community leaders who can then spread the idea to the community. How can satellite data help you? What kind of prediction, what kind of response mechanism? So going to the local level also helps in terms of education. So education has to happen at the university level in terms of actually building analysis that can analyze the data. Education has to happen at the policymaking level, where policymakers are not sometimes get the data. So you have to explain it to them and have the patience to explain it to them. And finally, you'll also have to get down to the community level in terms of explaining why this is vital. But without demonstration, without actual implementation, sometimes you might get pushback. So you'll have to be prepared for that as well. But trust can be built, and it's a long time process, Meryl. It doesn't happen
Absolutely,
quickly.
yeah, of course. So, and Namrata, another question for you. Is there tension between civil and military technologies and applications? For example, intelligence, surveillance, and reconnaissance. Or is there more integration between military and commercial space? We know that the Pentagon issued its commercial integration strategy recently. Is there any alignment you see between commercial and military, and how does that benefit the end user?
That's a great question. I thought about that question and I looked at some of the policies, not just in the US, but also in Africa and India, for example. So the tragedy is that in Africa, there are several military institutions that have Earth observation data capability, but they do not contribute to sustainable goals. Very clear. There is no coming together of the civilian and military Earth observation data. So that's one of the findings of several studies. And I've heard this in my conversations with African colleagues as well, that while the military has this capability, they do not necessarily contribute to the sustainable development goals, for example, poverty alleviation, response to disaster in that context. Now, when you look at the Pentagon strategy, there is a tension because I read the strategy. And so the strategy talks about integrating commercial remote sensing and other capabilities for purposes of enabling the US military to respond in terms of conflict, right? So there is a difference there. So the end goal, in all likelihood, for a military is to respond in times of crisis. And I think they've learned lessons from Ukraine that if you do not integrate commercial capability before a crisis, you will then be left scrambling or not actually use that capability. And then finally, one of the biggest tensions between the military, and this is across the world, not just the US, be it in China, be it in India, be it in Africa, is classification. Yeah. Classification is a major issue because they have the data. They have that resolution we require for responding to disaster, for responding, for example, to some kind of crisis, not just conflict. But because of classification level, the ability to talk, the ability to integrate is a major challenge. And then finally, regulation is not keeping up. So even when you look at the tension, you have so much commercial capability, but what do you share? Will you get into trouble if you share? For example, commercial sector, that is a big challenge. You have IATAR that basically comes in, the international traffic alarms, which the US has. You have other countries with classification levels. And so when we talk about open access, that might not be the best quality data you have, and the military tensions of national security limits sharing as well. And so that's where we probably need international treaties. But you see at the level of the United Nations, it's becoming not that easy to come up with a new treaty. So we might have to find a solution could be to find other ways of coming together, say a normative framework that talks about that kind of response.
Thank you so much. And now moving to Juan Carlos. First, I want to ask you if you'd like to comment on anything that Namrata has said.
Thank you very much. Apologies again for being a bit late, time difference. I think that from my experience in disaster response efforts, I've seen a very strong link between the military and the disaster management agencies. The armed forces end up being a very strong partner, probably not in the framework of high resolution data in that sense, but in the logistical support efforts, I do see it. In my view, that's the strongest link that I see between the military and the civilian institutions is in responding to disasters as quickly as possible with all the assets they have. whether it's airplanes, helicopters, trucks, soldiers, officers. They are there to support their country, and that has been my experience over the years. And of course, they're not into sustainable development. The armed forces are not really into sustainable development, and they leave that to the other social ministries. There's an entire cabinet probably dealing with sustainable efforts. So I don't think they look into that issue. It's not really their mandate. That would be one comment. I think that the other comment I have is on the trust of data. My experience with developing countries, first and foremost, is if I take a map to a rural area, as for me, if I try to take a radar imagery, I wonder if people will understand that, and it's going to take me a very long time to explain that, to see what it does. But they will understand very well a map of a flooded area. So there are things that we have to be able to adapt our language and the tools we bring to truly the last mile, because they may not be able to use it as quickly as we want. And so we do work with national disaster management agencies. We train their staff to build the skills so that they can take advantage of all the opportunities that the space community is making available. But one of the challenges we often find is that there's staff rotation, so we have to keep on training technical staff on these things. We also have to keep raising awareness whenever there are new heads of institutions. After electoral process, as you can imagine, heads of disaster management agencies will change. We have to go back and raise awareness again about the benefits. You probably come from a developed country, but I would ask people in a developing country, when they were 20 years old, what is the view of a satellite imagery? It's a beautiful color picture from 400 kilometers above. And this is what we see in the newspapers. It's a beautiful color picture, satellite image, it is. But that's the wrong idea. So we have to explain you can get a lot more than just that beautiful color picture. Images come in bands, and you're able to do arithmetic with the bands to really extract a lot of things. It goes way beyond the visible of that beautiful color picture. It goes to the infrared, to the microwave, and you can see a lot more things. So we have to do that explanation and take this notion that this is more than a beautiful color picture. And there are very interesting tools that we have to encourage their use, even though at times I think Google Earth Pro is probably in some cases maybe not yet used properly in disaster management, even though we do see some interesting things. The challenge there is when it becomes dependent on high internet bandwidth. This is the other thing about local levels. It's not that we don't want to send them a 10 gigabyte satellite image. It's how long is it going to take them to download the image? So we have to think differently and say, no, what they need is a service where they already have a map that's pre-processed somewhere in the cloud, and they just download the map, because they don't have the bandwidth to be able to do high size data files download and processing. So in my view, part of what we do at UN Spider is help raise awareness about those services that the space community is developing. Whether it's for floods, like the Global Flood Observatory, the Global Flood Awareness System, the GeoGLOW's ECMWF HydroViewer. These are services that already put out the maps there. So we raise awareness about those solutions. And of course, we put step-by-step procedures with open software to generate information in developing countries. And open software is something that we really stress, because a former speaker already mentioned how expensive a commercial license is. So if you put a commercial license, ERDA Senvia, $10,000 per year, 2 licenses, the head of the disaster management agency will prefer a vehicle over 2 licenses a year. So we have to come up with those solutions. And of course, we have to raise awareness about the value of information. Already Andrew was mentioning the benefits of combining high resolution and low resolution. Part of what we have to do is engage those decision makers in developing countries to recognize that they have to put some budget into buying high resolution imagery, that they don't always have to expect it free of charge. So we have to do that lobby and have them put a little bit of budget and facilitate that part, that there are national companies that are reselling the data, so it's easy to use for them. It's hard for a disaster management agency to go and buy a commercial imagery outside their country, because their national controller will request them to have a national bill from a national company. It's not like they can go to a US company or to a European company or an Asian company and buy imagery and pay it in US dollars. It's a major headache to buy with foreign currency for the disaster management agency. It's easiest when it comes to the donation. But we need to raise awareness about the value of data and information so that they can then exploit it.
Thank you. Maybe we can talk a little bit about the role of UN SPIDER in enhancing the use of space technologies and disaster risk reduction, specifically preparedness and emergency response. Do you want to add anything on this?
Yes, one of our pillars is bringing the disaster management community close to the space community. So one of the things that we do is basically raise awareness about those mechanisms that have been established by the space community to support disaster response efforts. There are 3 right now that are fairly well known. There's the International Charter Space and Major Disasters. There's the Copernicus Emergency Management Service, and then there's the Sentinel Asia. So those 3 facilitate access to geospatial information free of charge. So our aim is to raise awareness, enhance the use of those products. With the charter, they have the modality of authorized users. So we've already engaged about 25 countries in Latin America, Africa, and Asia as authorized users. So the disaster management agencies can directly request the activation and get the support directly from those mechanisms. So our role is to facilitate the links between those. In early warning, there's a difference because it has been my experience that the space community is more geared to respond. They have set up mechanisms to respond very much, very good, since 25 years ago. The early warning and the prevention is not there yet. So we are working with our partners, with our regional support offices, to develop procedures to generate products that are part of that risk reduction. Hazard maps. We have to speak the language of the disaster management community. They speak about hazard maps, which areas may experience a flood or landslide. And in many cases, we can use satellite imagery in combination with in situ data to generate those maps, digital elevation models. So we're trying to develop step-by-step procedures with open software to use that to develop hazard maps for floods, for some storm surges, for landslide susceptibility. We're also working to the extent possible to encourage the use of interesting products like the World Urban Footprint of the German Aerospace Center or the Global Human Settlement Layer of JRC, so that they can, disaster management agencies can quickly get an estimate of how many people may be affected based on that exposure information. But of course, it's difficult to say we can see vulnerability. For me, vulnerability is a very social issue. I've been on this for about 30 years now. And I can't really tell. Let me give you an example. If you look at a satellite image and you tell me which building in Turkey was going to fall before an earthquake, from looking at the roof, you just can't, because the physical vulnerabilities inside the walls, inside the beams and the columns. Satellite imagery doesn't help us see the quality of building materials. We see the roof, but so the vulnerability part, it's hard to say. So we say we have to combine what we can get from sales with in situ data, and we have to keep raising awareness about that. So we find there are 2 types of countries: those which have a space agency, like Paraguay, where the space agency is very committed to supporting their national disaster management agency. So we work with the space agency, we work with Alejandro, so that they can help their national disaster management agency. And we do see very interesting examples and useful examples of that in Africa, in Asia, and Latin America, where this is really working. And there are countries where there are no space agencies. And there what we have to rely on is a community of professionals from different ministries that we bring together and we train them on those step-by-step procedures so they can generate information. We usually find that the ministries of environment are the ones with the best skills when it comes to Earth observation. Probably because they have been dealing with the environment and there have been so many donations of satellite imagery and trainings that they have the better capacities. So we bring the ministers of environment, agriculture, disaster management, geography, health, and other institutions into these technical interinstitutional teams to train them on the use of solutions developed by the space community.
Thank you so much. I think we will conclude with the panelists, but we will take some questions from the audience. Let's start with the questions. And please feel free to answer. The panel has spoken about the data science challenges of extracting information from the abundant data. However, do the panel wish that certain data were better quality, i.e. better temporal or spatial resolution types of instruments? Anybody would like to answer this?
I have an opinion on that. So I think I was
Yes,
the one who
please.
said there's lots out there. We need to use it better.
Mm-hmm.
Obviously, yes, there are also new data types that we could get. My personal favorite is high resolution hyperspectral data. I think that there was a lot that we could do if we had better hyperspectral information and it was broadly available. Temporal resolution, absolutely. To have Sentinel-1 data, once every 12 days or once every 6 days if we have 2 satellites in orbit is not enough to do what we want to do. But again, going back to the other point, if we pool all these resources, we actually have better temporal resolution than you might think, but we're not pooling the resources. We tend to have a project-driven approach, a program-driven approach. We work with Sentinel data or the NASA data, or we work with a commercial satellite, but we're not pooling everything together. And on that point, I want to go back to something that Juan Carlos brought up, which is we need to convince disaster management, civil protection agencies to put up money for commercial satellites. I don't think it's ever going to happen. I don't think they're going to pay for it. They don't see the value of commercial data from satellites, Earth observation data, the way they see blankets or even cell phone communications in a disaster zone. And so how do we get access to that commercial data? Because I really believe it's important. I think actually, I'm throwing it back at you, Juan Carlos, I think it's the responsibility of the UN or of the international community, the World Bank, GFDRR, for example, to create a fund where money is put in to purchase commercial data for the generation of satellite information products at times of disaster. And there is a way to access those resources for countries, and the countries then don't have to pay for it. They said they would get access to a certain quota of commercial data for free to be used properly to generate information products. And I think this is the path to go forward, and we can find people that believe in this, that would be willing to start this. We've worked a lot within CEOS on demonstrators where agencies contribute free of charge what is typically commercial license data. It's made available free of charge in that context. But I think we can really up the game by putting some money in and dealing directly with the commercial companies and it could start quite simply with a few $1 million a year, we could make a huge impact. And then I think people would start to see the benefit, and then money would be available from organizations. I think that's the way to break this chicken and egg deadlock. Alejandro.
Thank you so much. There's a question for Filippa. It says your views on a new model of connected and smart EO as a service for risk data insights, warning, mobility, supply chain, for better risk reduction, mitigation, management. I was wondering whether there are danger of data availability being used as a political and commercial lever, and if so, are there any safeguards to prevent this happening?
That's a tough. I don't know personally of that ever happening, but I think it is something that we should ward against. The valuable stuff can always be used politically, I think, if we're not careful. Data is hugely important. Coming back to what Andrew said a minute ago, I think we all want more spectral bands, smaller pixels, more frequent. Of course we do. But one of the chief barriers, I think, is getting hold of the right data quickly. So it's removing barriers again, and I think it's a mistake to want everything free. We have to, things have to be paid for. Economies have to be supported. And I think a fund, as Andrew said, is probably a good idea to make that happen. It doesn't have to be spent all the time everywhere, but it can be focused to enable something to happen where it needs to happen. I think that's important. We need to make the most of our global economy, our global understanding, and not be afraid of it. Work towards using it for the benefit of everybody. I don't think I've answered the question, but I think that's because I don't really know the answer to the question. I think it's tricky. But yeah, we should ward against any kind of political pressure regarding this technology, which should be for the benefit of everybody.
Thank you. So the next question is, what specific Earth observation products are currently absent or needed for better crisis and disaster management? Anybody would like to take this?
I think that I've worked very closely on the recovery side, and I think that's one of the weak areas in terms of products. We do a lot in terms of response. For a week, for 10 days, we have all these data and information products, and then it all goes away. And we haven't really dealt with more than the humanitarian crisis caused by the immediate disaster. But what about real recovery? If we want to build resilience, we have to build back better. If we want to get a handle on recovery, we need to have better information products. I think the other thing that people tend to downplay is the timeline for getting these products into a decision-making cycle. So you can have the best product in the world if you haven't presented it to an organization that is taking a decision at the time that they take the decision, in a format that they can ingest into their existing operational structures. It's not going to be used. It'll be a pretty picture and it'll appear on the news, but at the end of the day, it's not actually being used to take a decision. And so we need to do a better job of building bridges. I like Namrata's discussion around trust. It is fundamentally a trust issue, but it's also an awareness and in French we say apprivoiser. We have to get to know each other. These two communities don't talk a lot. So you have the disaster community, the risk community, and the satellite community. They don't understand each other very well. So we need to understand each other better and understand at what point a decision is being taken. When we generate products for post-disaster needs assessments, we're told we have 6 weeks after the disaster to generate that product. We could do a better product in 12 weeks, but we don't have 12 weeks. So we work that backwards and say, what can we do in 6 weeks? After that, we'll give you another product, a better product, a different product, which you can use from a policy point of view for broader things. But for those decisions that you're going to take with regards to the donor community, for example, 6 weeks after the disaster, we'll do the best we can. And we will guarantee to deliver it on time in the format that you're looking for so that we can work with that product. And I think that has to happen a lot more often.
Thank you. It's an excellent point. We've got a question on a sensor called Astra-Terra since January 2008, and somebody said that it's for flagging soil indices. The data set can be used for post-disaster impact on soil. Are there any freely available alternatives for Astra? Because apparently it's paying. Anybody is familiar with Astra would like to answer this?
I'm very familiar with Astra. Spent a lot of time looking at wonderful Astra data, and many of us in the geoscience community would love to see another Astra satellite. And yes, it is no longer completely functioning. There's no free alternative that offers everything that Astra offers, but of course Landsat gets better, more capable, more bands. Sentinel, these things together, Astra and Sentinel-2 together, or Landsat, and they offer something similar, but not entirely equivalent. There will be new hyperspectral satellites coming online. So Prisma, Nmap are already here, and they offer not everything that Astra offers, but they're better better than Astra in some respects and less capable in others. And it comes down to understanding what you want to achieve and which is the most appropriate data set to use. You know, there's no ideal perfect sensor that can do everything. We just need to understand what each one can do for us, so that we're not just offering, as Juan Villagran said, a pretty color picture. We are offering something that's useful, a range of products that are of practical use to people on the ground. And he also mentioned the difficulty of bandwidth and accessibility. And I think I heard somebody from Map Action talking about what's actually needed on the ground to help them deal with disasters. It's often just paper maps with important, useful, thematic information on them. So that means that we, the technical people, have the responsibility to produce the things which are actually required and make them available in a format which is required. And I see these great barriers between the technical community and policy up, but also between the technical community and the people on the ground who need the usable products. And again, those are barriers which we need to work on. We've come under criticism in the past for doing wonderful things in research, but we produce papers, whatever, but actually translating that to something that's useful by stakeholders is something which is eluded often by the research community, and this is a problem that I see. Similarly, translating our understanding up to government through policy and etc. is also something which is challenging. So there, I think, are more problems. I don't have any solutions to those problems, but I see that this relates to that. This question about data and access and what's applicable and what's available is a problem, a much wider problem.
Thank you.
Yeah, if I may add to that quickly.
Please. Sure.
Yeah, so I think, Philippa, you raised a really important point, and I pointed out in my response as well, that there has to be that integration of policy, academia, and implementation. So, and also the communication level. So there are lots of peer-reviewed articles which we each other read, but how do we translate that to actual policy briefs that are understandable at different levels is vital. And I'll end by saying that I grew up in Northeast India, which is prone to floods every year. Since with the Brahmaputra River flooding, people live there. It's highly populated. Japan is an amazing example of living on an earthquake-prone zone and responding to it. Northeast India is a bad example of people living in flooded areas. My family's houses would be full of water, unbelievable. So the point I'm making is that what India has learned in terms of response is disaster response. The military is involved very heavily. But the tragedy is that you have this great EO data that is offered. You have satellite imagery that even tells you where the flooding might be, and the floods. So they do a pattern analysis of every year and stitch it together. And so you can actually say that these are where the floods are going to happen. These are the areas prone. But then, as Philippa was mentioning, you have this amazing, so Earth observation, in my understanding, helps you in terms of predicting and forecasting where something might happen in terms of even floods. The challenge is that, first of all, awareness of the society. The other thing, which I think we really need to understand, is that sometimes societies do not have anywhere to go. So you might say that this area is prone to flooding. I mean, my family didn't have the ability to go somewhere else, you know? So they lived in those houses and managed the floods, you know? So I just wanted to bring that reality that sometimes we have the amazing data, the prediction, the disaster response, but local institutionalized structures, ability to respond, has to be also built, so resilient structures. And so my solution, at least to my conversations with people in Northeast India, is that there has to be the ability to not just look for the problem, but also how do you then go somewhere else to save yourself, right? To build those resilient structures. It's still a work in progress, but there is this community conversation happening. So there is a little bit of a way forward there.
Yeah, I mean, there's a question from the audience about this. It says, what is a way to democratize access to satellite data for humanitarian organizations so they can be better prepared?
I think Andrew answered it very well. So yeah, basically offer, as he was saying that, well, I mean, I was just thinking through, like, for example, say a government in a developing country, or countries that don't have access to power, to then put across money to buy commercial data. That's a tall order, you know. So commercial data, as you know, it's expensive, you know, to get it, and especially for specific areas, because you know that sometimes NASA and other capabilities do not offer that kind of specific resolution data, in my understanding, right? So now you want to buy for commercial, that can be expensive. So Andrew, would you like to repeat what you said? I thought that was brilliant.
Actually, I might link it to this next question, because it touches on what you've just said, Namrata. So somebody has put here that they really appreciate the effort of ESA, NASA, and JAXA. However, for emergency cases like flash flood, oil spills, etc., we need also the commercial data provided by private companies. And some companies agree to share data, but it's very limited in some cases. And I may understand this. Therefore, I wonder if the public institutions like ESA, NASA, and JAXA, via their collaboration, can purchase these data and share publicly. So you could answer all these questions.
They already do. I work a lot with the Committee on Earth Observation Satellites. The French Space Agency, for example, the Italian Space Agency, they have access to commercial data. They buy it from their commercial partners, and they make it available free of charge in these demonstration projects to try and showcase how the marriage of open data sets with commercial data can be beneficial for certain applications. So it's already happening, but it's not happening at a large enough scale. It's not happening with the key people in the disaster risk management community. It needs to happen at the level of GFDRR. It needs to happen at the level of the World Bank. It needs the Asian Development Bank. It can't just be taking place within space agencies, because those space agencies are not well enough connected to the risk community. And going back to that risk community, I mean, if we think of risk, we break it down. We've talked a lot about hazards. And it's true that satellites can do a lot for hazards, but risk is really hazards, exposure, and vulnerability. And the weak link in that information chain in terms of being able to improve our ability to manage disasters is exposure. And we have a lot of exposure information. It's collected all around the world, but there is no global repository for this exposure information. It's in different places. I've worked in countries where I know there are at least 3 exposure layers. You can't get the layers. They're out there. They've been paid for already. They're available to some people, but not to others. We need to have a global repository of exposure layers. And these exposure layers are not going to be generated by satellites. They're going to be generated by some combination of on-the-ground stuff and people going, you know, building by. We need to know where all the buildings are and what the buildings are made out of. And it is surprising to see how much information we have, even in the developing world, in places like Tanzania, Kenya, Malawi. I've worked a lot in Malawi. Someone said Malawi earlier. We have a wealth of information, but it's locked up in somebody's computer somewhere. It's locked up in another place. I think it's the responsibility, just like for the commercial satellite data, it's the responsibility of the global donor community to create a fund, to pool the resources and say, for certain applications, it doesn't have to be freely available all the time, but for certain applications, for risk-related applications, it will be made available to qualified partners who are generating information products. Same with the classified cooperation. We heard how the military is very good at using commercial data, but not so good at making their classified satellites available. Well, actually, it's not true. A lot of commercial people, a lot of classified information is used during crises in places like France, the United States, not in Africa, granted, but by the Western world. These classified satellites are used to add information to an information product, and then the public has access to that product. They don't have access to the classified imagery, but that's already very, very valuable, because you can generate an information product that will be useful without sharing the classified imagery. And I think that's a best practice that could be generalized within the military communities, and that would help them share some of their wealth of information during these crises. So again, a lot of this could be addressed with just better practices with what we have already, my own opinion.
Yes, if I can add a bit on that, totally agree. And also the International Charter for Space and Major Disasters has the commercial providers as a source of data, and they provide us through this mechanism. And also it's mentioning that it is very necessary to integrate more data, in situ data, in order to complement these data sets. In the group of Earth observation, for example, we coined this term, the geointelligence, that Earth intelligence, that has multiple layers of data that can extract more value information from them. I think this is we need to encourage to integrate more in situ data and many layers of data to improve the interpretation and to lead to more robust scientific insight, informed decision making, and effective solutions for these global challenges. I think this is a very, very good point regarding what is still missing. That we need to integrate more data.
Thank you so much for this. I think we're gonna end it with the last question. Numerous AI technologies are being applied in estimation, prediction, and management, specifically for the recent advancement in large language models, so LLMs. Have there been any methods or practical cases of utilizing them in crisis and disaster management?
Yes, and I mentioned one earlier.
Yeah,
so go ahead, please.
Yeah, so I answered that already in the chat. That, for example, you can use a large language model on the social media outlets and start to find the sentiment in that data source. And I definitely would like to get out of the Earth observation discussion in emergency response, because I don't think that we have the temporal resolution to really support by Earth observation from remote sensing. So you are again back to what Felipe says. Earth observation is much more wider. It's an Earth observation. You're observing the Earth, and you have many more sensors that you can use than the remote sensing in space. You can use humans as sensors, and that's actually being used in, for example, Eastern Europe. I think it was a pilot project in Slovenia, where people were having a special app that when a certain emergency happened, like a flash flood, they could directly notify the institutions, and there was an action plan executed at the spot at the time. So then you're using a human as a sensor, and I think that's an underutilized aspect of Earth observation. So yes, large language models are able to help and to assist, but perhaps not in remote sensing at the time scale that we needed, at the time that we needed. So it is more in the sense of early warning systems and direct response.
Okay, anybody would like to add anything on this? Okay, so I think if we could get a short message from each of the panelists, what is the takeout of the webinar before we conclude? Maybe we start with Alejandro. You muted.
Yes. Now I am okay. I think we can do it together. This is one of the main takeout. It's essential to continue investing in the capacity building activities to foster a collaboration across border and empowering local communities to harness the potential of space science and technology. We can build a more resilient and sustainable world, which the Earth observation serves as a powerful tool for managing these crises and disasters and protecting lives and safeguarding our planet's future. In conclusion, I can say that let us embrace this transformative potential as a globally inclusive approach to crisis and disaster management, working together to build a safer, more resilient world for present and future generations. Thank you very much.
Thank you. Andrew?
I think I've said several times, integration of data for better information. I think this is a key point, that we have a lot of data already, but we're not doing it well enough, this integration, and it's because we don't have the resources to do it. We need some money dedicated to integration, and that's very closely tied to capacity building as well. I think we need to invest in capacity in Latin America, Caribbean, in Africa, in Asia. There is not enough capacity locally to properly exploit these things. And then finally, I agree, I think it was Namrata was talking about bandwidth, the need for bandwidth. We have the tools, again, available. We have satellite, this can do this. We have a lot of tools available. It's not that expensive for the international community. We shouldn't be waiting on each country to be spending on this. We need, as a community, to come together and say there are areas where there is a dearth of capacity, and with a little bit of money, we can bring them up to a more acceptable level so that they can be players in this global community and participate together. We're in it together, as Alejandro said.
Thank you. Gijs?
Yeah, no, definitely kind of mirroring what Andrew was saying. We need that integration. There is so much data out there. Also utilizing the space that goes up, so kind of shared payload missions, more and better integration of the sensor design. Like Filippo was saying, have to know what we are measuring, so we are just sending a satellite up, but you should utilize that correctly and then bring the data back and share the data where it is needed and when it is needed. So I think we have a role there to play as a community to raise that awareness that the data is there and that we should use it for good.
Thank you so much. And Juan Carlos, please.
I would echo what the colleagues have said. It's important to encourage this integration of multiple sources of data. We at UN Spider basically try to do capacity building effort and to raise awareness about these solutions developed by the space community. So we need to continue that effort, being able to reach a lot more stakeholders in developing countries. That's a real need. I'm very grateful to the space community for providing so many opportunities free of charge. They're really trying. One of the challenges that at times we find is that in developing countries, we don't see these many open data policies at national institutions. They still cling to their data, but they're happy to get data from the international community. Andrew, you were commenting a little bit about the UN pooling resources. It would be great. I was thinking we tried that in 2011 in UN Spider. We tried to come up with a small fund to buy satellite imagery. And the answer from the Committee on the Peaceful Uses of Outer Space that you're aware of was beware, because the Charter is providing all of that information free of charge. The Charter is already doing that. You should not duplicate the Charter because you will discourage the Charter from doing its work. So we are very careful a little bit about how we don't mess up the International Charter and what it's doing, because we understand it's doing a really great job and we don't want to discourage the Charter or Copernicus or Sentinel-Asia from doing their work.
It may be time for a revisit of that. It may be time for a revisit.
Okay, very good.
Sorry, yeah, just very quickly. It has not been mentioned, and perhaps people are not aware, but there is the Norwegian Institute for Environmental Studies, and they are in partnership with Planet, and the NECFI data set is being made available, and I would say that would be a very good step forward. And also IC is doing the same thing with their radar data in strong partnership with ESA. So data is being made available, but not yet at the scale. It has to speed up, it has to ramp up, but luckily people are thinking that direction. So sorry, Johan, I just wanted to bring that up in this discussion as well.
Sure. No, I think there are excellent solutions, and we have to raise awareness about those solutions and encourage their use.
Yeah, and that's what we're trying to do today. Namrata?
Yeah, so I think I would say that when we talk about I think we have now recognized that Earth observation is vital. I don't think at policy level it exists. That's my recognition. Reading through different policy documents of different countries, I think geopolitics does play a role in terms of sharing. Because space is so much, I think we have to recognize this reality, otherwise there could be frustrations that there is this national security aspect of data sharing of specific territories and areas. And so that plays into sometimes this open data access of different nations, especially developing countries where borders are still disputed, they have conflicts about territory. So that all plays in. Think about India, China. I mean, I lived in the area of India that was disputed between India and China, and the river would flood and the local community, and there was no sharing of data between India and China in terms because of the upper riparian and the lower riparian issues, right? So that's something we have to bring in mind. And I'll end by saying that I really like what the panel talked about in terms of integration of data. We've recognized that. Now, how do we do it, right? So that's the key question. I was thinking that it probably, I don't know, this is a thought I had, that we do have regional institutions being built around space. For example, the African Space Agency, the Caribbean and Latin American Space Agency. ASEAN is now talking about building their own space agency, and Earth observation, remote sensing are vital. Look at the Africa 2063 agenda. Remote sensing is number like high up, right? Sharing of data. So then, can we actually think about building a funding structure through regional institutions, which can take advantage of their own spacefaring nations? We do have several very important nations within those regions to build that kind of collaboration besides the United Nations, right? So is that a possibility? And this is a thought, I thought about it as I was listening to the amazing discussion. And so I think I will end with that.
Thank you so much. Thank you, Namrata. Philippa?
Gosh, I agree with everybody else just said in their summaries. I think from listening to everything we've discussed, it seems to me that there's no problem with the hardware, that we have the technology, we have the data. The problems are soft things. They're to do with national and international policy or local policy or awareness, stakeholder involvement, money. I think that's what we have to work at, and that is, of course, the difficult bit, and that's the bit that's hard to quantify, hard to get at. The availability of, you know, the exposure information. These are big problems, and that's what we have to work on. But I also would say that there is a problem with perception at the kind of the nitty-gritty end, the local end, and I come across this time and time again, and there is this perception that Earth observation data is difficult, it's expensive, it's a bit frightening, I don't want to stick my toe in the water because it might be costly, and we also need to tackle that too, because it is not it's, you know, it's pennies per square kilometer of data. It's very can be very cost effective. The expensive part is exploiting, interpreting, using the data, how to get the most out of it for the, you know, the maximum benefit. But so this is what I see as the difficult part. It's everything we've been talking about for 90% of this panel is all those soft barriers to the real exploitation of the power of it. That's what I see.
Thank you so much. So I'd like to thank you all very much. It has been really very informative. The subject of Earth observation is crucial in managing not just crises and catastrophes, but in preserving our beautiful planet and sustain our very daily existence. So thank you so much for all the panelists. Thank you also for the wonderful audience that we had today. And I'd like to give special thanks to Tim Gordon, who put this whole thing together technically, and to our designer, Happy Accident. And thank you, you've been a fantastic audience with all the questions. Just want to make one last announcement. So Astra-Terra with cars at Imperial College is going to be doing more and more Earth observation events. So please stay tuned. And thank you again for being here with us.
Thank you, Mireille.
Thank you.
Thank you very much.
Thank you
Thank
very
you,
much.
everybody.
It's been a pleasure.
Thanks for listening.
It's been
Thanks
really
for
a
your
pleasure.
thoughts.
Thank you.
Thank you.
Very much.
Take care.
Bye.
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 Bye-bye.
Bye-bye.